Hi and welcome to the second video in my series on building cost-effective integrations with Apex, ORDS and the Oracle database. In this session we're going to look at three specific scenarios related to fetching data from other systems. We're going to look at three different techniques. The first is real-time integration with a REST API using Apex REST data sources, which is a declarative option of Apex. The second approach we'll look at is doing a local sync, so again using a REST data source, but to use that REST source to sync to a local table, again using declarative options. And finally we'll look at syncing changes using an Apex automation and PL SQL code. So the first scenario in this scenario we have an Apex online store that's querying data from an MDM system which has our items. So that MDM system has a REST API, and we've created a REST source in Apex to query that REST API. We can then attach that REST source to just about any object within Apex. In this case it's an interactive report, and we can query those items in real time using that REST source to see the data in our interactive report. And this is completely declarative. So the pros of this approach are we're looking at current data, so it's querying that data in real time across the REST API. We're not duplicating the data in two places, and it's a low-code solution. On the con side, it can be a little slow because we're querying these records across the network. That can be obviously a lot slower than querying from a local table. And it's also very slow in terms of joining data with local tables. So in this online store example, if we had sales order lines that we wanted to join with the items coming from the MDM system, we have to bring all the items across to a local database before they can be joined with our sales order line table. And that's going to be quite a slow process. So this approach is best used for lower volumes of data and situations where we don't have to have local joins or joins with tables in our local environment. The next approach is to sync to a local table using a REST source. So we're using that exact same REST source that we set up in the previous slide, but now we're enabling REST source synchronization. So this allows us to attach a schedule to that REST source and provide a local table, and Apex will, on that schedule, sync the data from that REST source to that local table. So now we have essentially a copy of that local table in our database that's synced for us by Apex. This gives us fast local access to that data. It's still a low-code solution, and it's a little bit more resilient because if that REST API fails, we still have that data locally that we can query. On the con side, the data is now not current, so no matter how frequently we sync that REST source, it's still not going to be completely up to date. And we've also got the data duplicated in two places now. Not necessarily too bad a thing, but it's something to be aware of. And the sync times can still be quite slow if you're talking about hundreds of thousands or millions of records that you're syncing. So this approach is more suitable for higher volumes and for local joins, where we're joining with local tables. So it would be a good approach for our Apex online store. The third approach is a little bit more complicated. So this involves creating an Apex automation. So that's the feature of Apex that allows us to run code on a schedule. That Apex automation calls some PL SQL code. And then that PL SQL code is using Apex Web Service in order to call the REST API. This allows us to be a bit more precise about the parameters that we pass to the REST API. It allows us to call REST APIs in sequence. So if we're looking for sales order headers and sales order lines, we can grab the headers before the lines. So it just gives us a bit more control about the way we sync that data. And sometimes this can lead to performance improvements. So for example, if the REST API supports fetching only data that's changed since the last time you ran the query, then we can pass those parameters through PL SQL. So this approach again gives us fast local access to that data. It can be faster synchronization, depending on the REST APIs we're calling, and it's still more resilient. On the con side, we still don't have current data, and we still have some data duplication, and it's also a high-code solution. We now have PL/SQL code to maintain. But this approach is great for very large volumes of data, when we've got complex REST APIs or complex synchronization logic, where we have to call one API before the other. So some examples of calling REST APIs and fetching data into the local database that I've been involved with. So I had a SharePoint integration where users would post files to SharePoint, and then we grab those files from SharePoint and post them to an AI service. Various integrations with Fusion ERP Cloud, where we would sync maybe lookup data or journal journal names, journal sources to a local database. Also involved with creating Quickbooks integrations, where we fetched customers and invoices. Harvest, which is a SaaS-based time entry system, and also NetSuite and Salesforce. So lots of different integrations with other systems, all using this REST source approach. So let's look at a demo now of fetching customers from Quickbooks. So I have this demo app. We're going to look at these two reports here and then look at some of the code behind the scenes. The other thing to note is I have a sandbox Quickbooks environment which has some customers, some test customers in it, and these are the customers we're going to be seeing showing up in our app. So this real-time report, this is based on a REST source that's querying data from Quickbooks. So let's take a look at that REST source. So the REST source is based on this Sandbox Quickbooks company that I have set up, and it's basically doing a generic query endpoint, querying this query endpoint, and then we're passing the columns that we want to query back from Quickbooks. This is one of the approaches to fetching data from Quickbooks. So that gives us a get REST API or REST data source that we can use to fetch data from that endpoint. And then we have this data profile which Apex created for us the first time we pointed it at that endpoint. So these are the columns in that REST source. Now that we have that REST source, we can plug it into components within Apex. So in this case, we have that REST source, QB customers, providing the data for that interactive report. So another thing to note about this real-time fetch is that we can also cache the results of that. So just so you can see, the last few queries, we've been doing a 200 GET request to that Quickbooks endpoint. If I go to the GET operation for the web source, the REST source, and I enable caching for all users, and I'll just say time it out after 5 minutes. If I query that report one more time, so this time it went out to fetch the data, so if I do this, you see we've got one more request there. But the next time I do it, so Apex has now cached that result, that whole JSON, into a local table. You can see that's almost instant. And if I query the web service activity log again, there was no request that time. So what Apex does is it takes the URL, and based on that URL caches the result into a local table, but it caches the whole JSON document. So it still has to parse the JSON before it can output it in the report, but it's still way faster than having to go across a network to fetch that data. So this is a really good way of speeding up your REST data sources if you don't need that data to be instant. Still not great if you have tens or hundreds of thousands of records, because you're still having to parse that JSON each time. But it's great for smaller payloads if you want to really speed up how those interactions with that REST source work. So the other example I have here is customers in QuickBooks Online synced. Nothing too interested in this one. It's the same report. Oh, actually, let's just go back to this one just to prove that it is updating in real time. So I take this ABCDEF customer and edit it. GHI in the end. So you can see ABCDEF. If I just refresh that, nothing happens because we still have caching on. So let me turn the caching off. I'll just purge that cache. And now you can see that newly updated customer name. So that's all happening real time. So let's look at this QBO synced. So this is looking at the same customer data, but this is using a REST source with a synchronization. So I go back to my REST sources. You can see synchronization is turned on, and it is syncing this data every day at midnight to this table's CNQB customers. So it's using the exact same REST data source with a couple of extra clicks to point it at this table. And then if we look at that report, we can see that's a plain old SQL query on that table. And you'll notice that ABCDF is still pointing at the old name. But if I go back to the REST source, and run it right now, run the synchronization now, you can see the customer name is now changed. So that's two really good approaches to synchronizing data, super low code. Alright, that's the end of this video. Stay tuned for the next video where we'll look at receiving data from other systems using Apex ORDS and the Oracle database.